All right. So are we here? Looks like it. And are we making sound? Yes, we are. It's only 11:29, so we got an extra minute or so. So we'll give people a moment. For those of us that are here, assignment 9, once again, it's a big one. We've hopefully been working on it for a little bit. And I had posted something in the Discord on both Saturday, I think, and yesterday. So the post on Saturday was that it's due tonight, right? And the late deadline is now tomorrow. So you have a few extra days to get it done. And the thing that I posted yesterday was, does anyone, if you're struggling with something and you would like to see me, code something up like it in front of you today, let's do that. And so there's a few that I will not do. The swap function I won't do because we already did that. The sorting function I don't think I'll do because we already did that. I will be doing a bracket operator today. I may have already done a little bit of that last or 2 weeks ago, but we'll be doing it again today. So really the only ones, we've also done a head insert in the notes, so you know how to do that. That's like your add to top of deck. The one that you haven't done or haven't seen yet is remove from top of deck. And so we'll kind of do something like that today. Though if you want to see a simpler version, let me know. And then other than that, I think really the shuffling deck function might be a little confusing for some people, so maybe I can give out some pseudocode for that. But I'll only do it if someone says anything about it. Yeah, and then other than that, there really isn't too much that needs to be done. The assignment operator overload, there are a few problems with that. Loaf is just going to spend a little bit of time with us while I'm chatting away here. We will be going over doubly linked lists today and on Wednesday. Just some more examples of that. And so while we're doing that, I will be doing a copy constructor, and I will be doing an assignment overload and even a clear deck function for that doubly linked list. So even if we get to that today, you might be able to see a little bit how that might be done. And I will also describe some of the problems that people have had with assignment 9, so maybe I can help you guys out there a little bit too. So once again, just let me know, and I'll see what I can do. The first thing that we're going to do today is we are going to just kind of look at the syllabus so we can get an idea of where we're at in the semester, because we're coming up here on the end, right? And then, given that there was a test last week, I'm just going to say a few words about that, and we're going to look at only a few problems that I probably, or I won't say I did not cover enough, obviously, and so we'll just talk about those before we get into the code today. So, to begin, I kind of just updated this. I haven't uploaded the new one yet to Web Campus, but this is kind of the rough outline. So, what I need to do is remove this week 15 here. We won't have this, I'm pretty sure. So, if I look at my calendar here, this week we'll be looking at more linked list stuff. Next week is, I believe, the study week. And so we're actually just going to take that to look at stacks and queues. Now, this is a pretty easy subject given that we've already covered memory allocation and even linked lists. So stacks and queues should be pretty light. Linked lists in the memory allocation this semester, probably the most hard to comprehend and get our heads wrapped around. Stacks and queues will not be too difficult. And I also need to remove exception handling. I'm just keeping it on here in case we have a few extra minutes, to look at that, but I'm guessing we won't. And then after that, we have the final exam. So you can look at that stuff. I'll even just pull up the link and maybe post it here in the Discord. Let's see what this pulls up. And so let's figure out where we are. So we are a Monday, Wednesday class, and we are, our class starts here, right? We're 11:30. Excuse me. And so I guess we kind of have some options here. Let me look here. Okay, here we go. So this is our class time. This is when it starts, right? 11:30. So it looks like our final exam is going to be on Wednesday, May 12th from 10:10 to 12:10 p.m. I'm pretty confident this will be good for everybody because the way that these schedules are organized is that there should be no other final exam overlapping with this unless your other classes are kind of going out of turn. So I'm guessing that they're not. And please let me know sooner than later if this doesn't work for some reason. Let's figure out why it doesn't work and see if we can do anything about it. But once again, this will be our final exam date. And I just posted the link for that in the Discord, so you can reference there. I will upload a study guide. I'll try to condense everything that we've done, and I'll upload some answers. And since, that final exam is going to be the whole semester, it's cumulative, it'll be the same format, and there will be a full program, but you will have extra time, and I will keep in mind that this last test, pretty much everybody ran out of time, and nobody had completely finished the last problem, at least from what I saw. Rather, I'll say nobody got full points on that last problem. And so I do understand that timing definitely was an issue for this test. So I'll keep that in mind as the final is coming up, and I'll see what I can do to make a decent test where we don't have to curve it as much as I did this test. I mean, that's at least my goal. So if there's any questions on that, please let me know. We're going to do the same lockdown browser thing again. So we'll close out of that, and we're pretty much done with that. So let's just kind of scroll through the exam real quick, and I'm just going to talk to you about which questions really kind of got people. I think we're having an internet hiccup real quick. It looks like we're still kind of here in the red. Let's see, I've got a question here. Yes, so that's a great question. I think we're coming through okay on the stream now, so I'll just start talking again. And hopefully it will pick up here again. So Red Rose asks, do you know where we can get practice problems for C++ topics like recursion? Because it takes you a while to come up with the solutions. And that's a great question. And I will look for that, okay? Right now, off the top of my head, I can't come up with anything. I just have all of the, common recursion problems kind of stored in my head. I know that we covered the power problem, right, and with recursion, and so the log question was on the test, and the log was kind of just the reverse of that. And then the delete, you could have done that recursively, but that is palindrome problem definitely confused some people, and we hadn't done one that's like that. So I'll see what I can do about finding some problems, and maybe developing my own that at least will mimic something that's on the final exam. Because once again, recursion is definitely like, it's just a method, It's not like this is the right way to do it. It's like you're going to have to, use some critical thinking skills. So practicing recursion is definitely something that I'll look to help you guys with. So thank you for that question. Looks like our stream's in the green again, so I'm happy about that. Now let's look at what we can talk about here. Okay, so this one, I thought, I really didn't cover this one. I maybe said something about it, but I don't think I was very clear. And this one definitely got some people. So question 3, probably can't read it very well. I'm trying to make it bigger here, but it, this web campus formatting is miserable. So it says, when is a virtual destructor necessary to avoid memory leaks? And now, if you go look in the notes, I really didn't say anything about it. I did say something about it, but it was not any sort of answer to this question. And so the appropriate answer for this, in short term, is when a derived class, this is an inheritance question, right? This is a virtual problem. And this is when a derived class contains a pointer and a base. And then, so roughly this would get you the full points. Roughly. But this is not necessarily descriptive enough. If you were to say an additional thing to this, also, there will be a pointer to the base class containing an object to the derived class. So that's kind of roughly how I would answer this. There we go. In that, if you think about how virtual functions work, we're just specifying the order in which the functions get called, right? Or which function gets called. Now, constructors and destructors are different in the sense that in inheritance, a constructor for every class that's inherited from will always be called, right? So in our player and warrior example, if we instantiate a warrior, we will first call that player constructor, and then we will call a warrior constructor. And as the same thing to happen with the destructor, if we, if a warrior goes out of scope, the destructor for the warrior will be called, and then the destructor for the player will be called. And so if we happen to be using a pointer to the base class containing an object of the derived class. So in this case, we would have a pointer to a player. And that player pointer would contain a warrior object. And so when that pointer is deallocated, we need to call a destructor, right? And so if our destructor for our player class is not virtual, the runtime will interpret that as a player object, right? And so let's say that warrior class contains some dynamically allocated memory, but if the destructor is not virtual, then only the player destructor will be called. And so when that happens, then you're going to miss that pointer, right? And so some people also said, like, you know, to maybe to enforce the order of destructors called, especially when derived classes contain pointers. So these are both kind of some acceptable answers to this question. Are there any questions that you guys have about this problem? A lot of you guys did, you know, kind of mess it up, and I tried to give some points where I couldn't, and I'm sorry that I didn't cover this enough before. So, you know, take a screenshot of that. Maybe I'll put this in the review sheet to make sure. You can also come back at this test. You should be able to see the answers to these questions. So you can see, excuse me, I'm kind of chest congested today. But I've got some tea here, so we'll get warmed up. But you'll see that the answer I use is kind of this one. Okay? So let's kind of move through here. You can check the answers for these. There's just a few specific ones that kind of got some people. Almost everyone got these ones right. I was very happy about that. With the operators, which ones are friends and which ones are members. Not that one. So this one kind of messed some people up, and I don't blame anyone for that, because we do have some negative questions on the test, right? There are some questions that we may ask, and there actually is no answer, right? So what we're asking here, which is what would the results of the multiplication in main be? This is actually a negative question, being that this function actually won't work, or this code won't work. Now, there's kind of two reasons why this one won't work. The first reason is that if you look down here, this example vector, I don't think it exists anywhere. I think one of you guys answered that properly, so I gave you full points. This example vector does not exist anywhere in this program, so the program wouldn't compile. But in addition to that, the most important thing about this is, and I have specified this before, that when you overload operators, the order of the parameters matter. So if you look up here, this bolded thing here, you'll notice that it takes a double and then a vector. And this is the only operator that is overloaded for this program. And so then if you look at this, you see that they're swapped, right? The double's actually on the right side, and the vector is on the left side. And so that's why this program doesn't compile at all, and that's because the order of the operands, they matter, okay? So that did kind of mess some people up, but that's okay, like I said. And just remember this. I mean, I'll try not to ask too many trick questions on the test. I know those aren't fun. But the order always matters. So please let me know if I need to spend some more time on that. Let's see. You guys pretty much all got that one right. A lot of you got that one right. A lot of you got that one right. A lot of you got that one right. This is palindrome 1. Go ahead and take a look at what I posted. You can also probably Google that one. That one's a very common recursive function. So yeah, that's pretty much the only 2 problems I wanted to go over. So we're going to go ahead and move on today. For those of you who are joining late, if you've got an assignment 9 question, go ahead and throw it in the chat and maybe we can work it out since that's due tonight. But other than that, I'm just going to throw another linked list example at you. I'm going to be trying to ask you some questions while we do it. And maybe we can make a little quick whiteboard just so we have something to reference. Because I never did this one. So today we're going to move on to doubly linked lists. We're just going to do a doubly linked list. Alright, Awful wants to do the assignment operator on the deck class. And I'm totally okay with that. Yeah, okay. So let's talk about it then. Let's actually go into our old code instead. Hopefully you're okay with that. I'm not sure if I did an assignment operator overload for that. And if we did, then at least I can show you that we've got an example of that. But it doesn't look like we did. No, we didn't. So let's go ahead and do that, shall we? Yep, let's do that. Thank you. Thank you for asking. I always appreciate that. Alright, so I don't mean to scare you with this code. You probably haven't seen it for a while. I'm going to kind of pull this out here. See if I can pull it over my face a little bit. That's pretty good. Alright, so we got a singly linked list here. It's a template, right? And you should recognize this code at least a little bit. And so similar to your deck class, right? You have your node, and you have your head pointer and your size, right? Since there's a pointer in here, I'm requiring you to do the rule of 3, right? So we definitely should do that here. And so here's the recursive print function that we did a while ago. Here's the iterative print we did a while ago. This is a bracket operator for nodes. That's also something we could talk about. Let's see. So notice here, here's what I'll say about this. Notice here that this operator is, this is the bracket operator. And on your assignment, I have this thing kind of backwards, right? So on your, I know I've talked about this before, but on your assignment, your operator is actually returning a node. And the reason for that is because I want you to sort with it. Now, I think many of you tried to use this in your assignment overload. Many of you try to use this. Now, the reason that is not okay, I'll even put it here. We'll leave it as is for now. But let's go ahead and do this assignment operator real quick. I'll tell you why it's a problem. And, you know, while I'm typing it out, does anyone want to tell me why you can't use this operator? At least on your assignment. Why can't you use this operator in your assignment operator overload? Does anyone have any ideas about that? So when you do an assignment operator, you always have to have a constant, and then it's going to be the SLL, and it's going to be the address, right? The copy. Or the right-hand side. Right? So your operator, your assignment operator always looks like this. And so in here, what we need to do is make a deep copy of the copy parameter. So we're a little behind. Cbase got an answer here. Yeah, and he says, because the compiler thinks it is unsafe to use the bracket operator. And the answer to that is yes, that's why. And so notice that this operator is returning a pointer. What is a pointer? A pointer is an address, and it points to something inside of the object, right? And so if you notice here, this is a constant. This parameter cannot be edited at all, right? And so the moment that you try to say copy 0, this bracket will return an address inside of copy. And your compiler is going to say, hey, this is constant. This is a constant parameter. I am not going to give you an address to something that's inside of me. Does that make sense? So you cannot actually use the bracket operator in here. Now, I've suggested to some people to do something like this. Now, like I said, it's backwards, okay? So don't get confused. And if you are confused, then tell me so we can work it out. But this here is actually constant. I'll make this constant. In which, if I have a function or an operator that only returns the type and not the address, then you can use something that's like a bracket operator. And so in your assignment, I said you have the node brackets, and then I tell them make this get card at int index constant card get. So I'll just kind of point it out here, right? So this one here corresponds to this, right? Notice that we've got, it's returning whatever the type is. This would be your card, and it's constant. And then up here, I had done this previously. This is my node, right? So I've kind of flopped them. So instead of the bracket being the unsafe one, this function here is the unsafe one, at least for this example. But they kind of work the same, right? This one just returns the node, and this other one returns the data inside of the node. Okay, so if you're going to do this operator equals, the first thing I would do is make this function here. Okay, and it works exactly the same way, just return the data inside of the node. So now we want to make a deep copy of this. There's a few things that we need to consider first. So the left hand side is different than the right hand side. So the first thing we should do is clear out the left-hand side, right? Just like we've done before with dynamic memory, we got to clear out this left-hand side. And so you probably have a clear deck function somewhere, right? You probably have a clear, here's my clear list, so I'm going to use this, okay? I'm going to use this one here. So what I'll do is I will call clear list on the head of our linked list. So we're going to clear out the left-hand side. Let's also make sure that our size is now equal to 0. Though you could also say this as well, right? We could do maybe the size is equal to the copy size, right? We'll do that instead. So first thing we should do is clear out our deck. We want to deallocate everything, and then we want to copy the size. Now, I'm going to stop right here for one moment. Let's also pretend, just like I'm making you do in the assignment, I'm going to ask you what the problem is here, okay? And I know I've helped some people with this already, at least one person. So if you're feeling vocal today, you can tell me what's wrong with this. But let's pretend we've got a copy constructor, right? Now this one is the easiest one, always, right? I always tell you guys that it's easy. And that's because you can do something like this, right? In which we call the assignment operator overload, assignment op. But there's a big problem here. You'll probably get a seg fault, right? So there's, does anyone know why I'll get a seg fault just from this, right? So let's say somewhere in Maine down here, I say SLL new list. I think it's going to be probably a string No, it'll be an int. And then I'll end up passing in this SLL, right? So here I call the copy constructor. So this new list is going to be a brand new object, And so first we call the copy constructor. And so we go up here, and boom, here we're in the copy constructor. And the next thing I do is I call the assignment. I call the assignment operator. So then we hop into here, and then we go call clear list. So let's go to clear list. And boom! What does that say? First thing it checks is its base case. Does the node equal null? So you're going to get, I mean, you might not get a seg fault here, but you'll get a seg fault here, perhaps. Or you'll get some weird things. If you run valgrind, it will say values not initialized, right? So nowhere in this process did this new list's head get initialized to anything. So this might happen to you on the assignment. So just keep this in mind. So notice here that we call assignment, and then this assignment operator already assumes that our head is equal to something, and that our size is equal to something. So what do you need to do? Well, you could do you want to initialize the thing. So go ahead and say, hey, head is equal to null, and go ahead and say size is equal to 0. Okay, so make sure you do this in your assignment on your copy constructor. If you don't have this, you might get seg faults, invalid reads, stuff like that. Make sure you initialize these. Because then you'll call clear list, and then it will hop up here. We'll say, oh, n is equal to null. And then it'll just return, right? No problems at all. So if there's any questions about that, please stop me. But we're going to continue on here. And let's see what else we need to do. So now, at this point, the left-hand side head is null, right? And the right-hand side is a list, right? So I might have said this in the PDF, but if that right-hand side happens to be empty, then there's nothing we need to copy at this point, right? So let's check that. So is the right-hand side empty? So you could check for this by doing one of two things. Or we could do both, right? We'll say if the copy, that's the right-hand side, right? I don't mean to be confusing. If the size is equal to 0, and if the head equals null, right? Or null pointer, whichever one you're using. I'm pretty sure that null and null pointer are exactly the same. Let's see, that one is 0, it says. What does this one say? That one doesn't say anything. As long as you're being consistent, it looks like I'm using nulls and null pointers. So I'll just kind of switch it up, you know? I'll just kind of switch it up real quick. Why not? Once again, like I said, it probably won't cause any problems, but I like to be consistent. Okay. So if the right-hand side is empty, let's just get out of here. We're done. Right? Left-hand side has been cleared. Right? And we did say that the size would be equal to 0. Right? Because the copy size is equal to 0. So we're good. We're good at this point. Else, right? The copy, or the right-hand side, is not empty. So now we have to do this deep copy stuff. It's time to do deep copies. And so what do we need to do? We need to go through that linked list on the right-hand side, node by node. Allocate this linked list on the left-hand side and copy the values. So it's going to get a little convoluted here, but we're doing it together. So let's get started. And always, the first thing we should do is handle the head node. And you need to do that. You need to do this because it is where everything begins, right? So at this point, you might want to say while something, you know, and then get in here and put all your code. But if you haven't handled the head node yet, it's going to be very, very hard because you need a starting point. And inside the while loop, unless you've got if statements, it's going to be hard to come up with a starting point. So the first thing that we should do is this. We should say, hey, our head, right? And if this confuses you, it's the this head, right? This head is going to be equal to a new node. And then we want to know that this head, its data, I think that's what I named it. Let me make sure. Yep. This data is equal to what's in the copy's head. So there's two ways to do this, right? Here's the hard way. Head data, right? That's the hard way. But what if you use your get card at function, right? Now, once again, it's backwards. I'm just going to keep repeating myself, right? Because I'm going to confuse you. So you won't be able to copy. Maybe just to my code. It's already too far done here. I don't want to spend too much time on it. So whichever one is constant, call this one. This one here happens to be constant. In your assignment, this one is not the constant one, but in this example, it is the constant one. So we're going to use it. So you could say, boom, copy located at 0, right? That is the head node's data. That's the head node's data. This returns the data in the head node. So now we have got the very first node. So let's do a loop of some sort. I'll probably do a for loop here. For int I is equal to 0. I is less than, how about the size? In fact, I won't start at 0 because the head node is kind of the 0th index, right? So let's go ahead and start at 1 instead. And let's go through the size. It doesn't matter which one we use because they're the same. And so now we're just going to kind of have to do some stuff. The first thing that I would say is probably get a node traversal going. You're definitely going to want this thing. Okay, you're definitely going to want this thing. This is your starting point. And this way you don't have to mess with the head at all. You don't have to mess with the head at all. It'll be capitalized, that's for sure. And so let's just kind of talk about it a little bit. What if, you know, the right-hand side list happens to be only size 1? Well, we'll start at 1 here, right? And so we'll say, is 1 equal to 1? There's one thing that I need to do here. See, this is why we talk about it. I should also prepare the next one to look at null pointer, right? Because what if size 1? What if that right-hand side list is only of size 1? Well, then we're going to want to make sure that it ends, right? We're going to want to initialize that next pointer to be null pointer. So what if it's size 1? And if it is size 1, then is 1 less than 1? No, it's not. This for loop won't execute at all. And then you'll just kind of return here at the bottom, right? So that's not a big deal. That's not a big deal at all. But if it's bigger, then we need to do a few things. So if it happens to be size 2 or greater, then we're going to need to allocate a node. Let's go ahead and allocate that node. Now this is kind of hard to think about, but you have to allocate it via the next node. Some of you might want to do this. Some of you might want to do this. But it won't work the way you think it'll work. You might say this, traversal equals traversal next, and then you'll say traversal equals new node. That is bad. It doesn't look bad, but the reason it's bad is now whatever the previous node was, it's not linked to this. Because what you said here was you said it's now null. Traversal now equals null, right? And then you say this variable that's containing null, let's allocate an address into it. And then you'll continue on. But your linked list will be a shattered list because you never connected them. You need to connect them. And how do you connect that? Is by allocating into the next node. That's a requirement. So this is bad, and this will cause problems. So don't do that. Do this one. Do this one. So allocate into the next node. And then once you've done that, go ahead and do this. There you go. So now that you've linked them, you did the linking, you can move to the next node. And now we can do this kind of insert stuff, right? So we can say something like, boom, traversal data is equal to, let's go to the copy. In this case, it'll be your kind of get card at I function, right? But in this case, we're using the bracket. And we'll get that data, whatever that data is located in the copy. If you weren't to use this function, you would have to make another traversal node. You would have two traversal nodes, one for the left-hand side object and one for the right-hand side object. But since we're using this nice function that we made, we only need to use this one here because this function has its own traversal node in it, right? So technically we are using two traversal nodes, but only in this function here we're only using one. And then let's prepare it, right, to make sure that when it's done, that the next thing is looking at null pointer. Okay. And so then that'll go through the list. Pretty much the first thing we do is copy the head. Right, this is the deep copy part. How do we know it's a deep copy? Because we call new. That's our deep copy right there. And then we copy the data. And then we're going to prepare it just in case, you know, that list is going to end. You know, we want to make sure that we're not looking at anything. And then we're going to prepare to traverse this list. We're going to prepare to traverse this list. So we'll just start at the head. And then for every node that's in the copy, we're going to allocate a new node, deep copy. We're going to move to that next node, and we're going to go ahead and put in the data, and we're going to prepare it for a potential ending. And when we're done, we should be good. So I will test this. I'll test this code right now to make sure it kind of works. Are there any questions about that? It's pretty, I mean, without all my comments, it's only a few lines, right? We got 1, 2, maybe 3, 4 there, and then this kind of block, right? This is kind of the hard one. But this should handle it. This should handle it. So what do you think? Are there any questions? I'll upload this code, you know, so you can, you know, use it. And let's see here. I just kind of want to call print list on my new list. And I want to specify that I'm looking at a different one. So our new list we'll call print list. And it will ask me, right? It will ask me if I want to do it recursively or with iteration, and that's fine. Okay, that should be good. So probably we're going to go to Bobby here. I'll pull this out. It doesn't matter. It doesn't matter. Copy constructor assignment op list. We hit 1. So this here is the list that we copied. And this here should be an exact copy of that list. Notice everything is in the exact same order. There's another way in our doubly linked list. I'll show you another way that we can do the assignment operator, where we kind of just call insert over and over again. Unfortunately, it doesn't work in the assignment 9 because when you add to the top of the deck, that's another one that you could do. I'll give you some pseudocode real quick just for fun. But that one worked, okay? Does anyone have a question about that? I'm gonna val grind it to prove to you that things are okay. And you can see here all blocks were freed, so we're good there. But I could give you some pseudo in kind of a weird way. Another way that you could do this is pseudocode. You could say for I equals, copy dot size -1. Start at the end of the list. Start at the end of the list. And then you'll say I is greater than or equal to 0, I minus minus. You could call this add to top of deck copy get card at I. So that would kind of look like maybe clear deck first. Size equals copy size. And then you do this. Now, the reason this one works is because in your other function, you probably handle, the allocating the new node. But you have to go backwards. You have to go backwards because you're kind of adding to the top of the deck every time. So you need to make sure that the last node in the right-hand side list is the first node that's inserted on the left-hand side list. So maybe you could try this even. And then, boom, your assignment operator is only 4 lines instead of, whatever this mess is. So that's that. So we're going to move on then. We're going to move forward. Are there any other questions you want me to look at? I mean, that one's kind of a big one too. But I think that one's good. So I wanted to do a whiteboard. I'm going to kind of just work on that real quick. Just going to make my nodes. Make my nodes. It's going to be like a little train here. And then we'll color it maybe a nice pink color. And in here we'll have the data. So this is going to be our previous. And I'll try to make this a little bigger, but it should be okay. In here we'll have our data. In here we'll have our next. So maybe we can just increase the size of that a little bit. And there you have it. Let's see. Oh, Red Rose asked about remove from top of deck. That's a good one. I'm going to kind of just give you the pseudo for that, if you don't mind. And you know, we can actually do it in this function here. Let's go ahead and add it. And obviously, this code's getting kind of nasty because I'm doing everything, you know, inside of the class. But you guys understand, and you guys should be educated enough to kind of find these things, right? So even though this code might look ugly, it'll be okay. Let's go ahead and do a function called type 1 remove top item, or remove head, right? We could do, let's do the head, right? So that's the same as your remove top card. So this one's kind of tricky. Red Rose asks, do we make a non-pointer copy first? And that's exactly right. That's exactly what you need to do. So let's give it a shot, shall we? So this one's kind of pretty small, but you might say something like, hey, the head, well, the first thing you would need is the return thing, right? So this is going to be the return data. And it's going to be equal to the head data. And then you need to save the node that you're going to delete because you're going to move the head forward. So there's really 4 steps here. Save the data, and then you need to save the delete node, which is equal to the head because you're going to delete it. And then you need to progress the head forward. All right, because no longer the head. So move it forward 1. And then you need to call delete node, deallocate the old head. And then you just need to return the return data. Yeah. So, yeah, that one's kind of hard to wrap your head around because you kind of have to, you know, jump some hurdles, right? You have to save, you make some save nodes, right? You got to save the data, and you got to save the node. Because, you know, I see some of you guys do this. Some of you guys do this. You'll put the delete after that. That'll never work because you're going to return before you ever execute that line of code, right? And so this one might look nice because you could say return the delete node data, but then you're going to have a memory leak because you never deallocated it. And so you have to have this kind of save data thing going on here. But that's how you do it, roughly. I mean, you'll have to do a little bit of converting, but that's how it looks. So I'll save that. Oh, and be careful about this one too, right? There's one more thing you should do. See, I forget this stuff too. Don't forget to do that. That'll cause you some problems as well, right? Make sure you make the size smaller. Make sure you make the size smaller. And in fact, there's kind of even one more thing you might want to check for, you know. So if you happen to have some bugs in your code and you ever call this function on an empty list, then you're going to segfault, right? Because the list is empty, and then you dereference it here. Dereference a null pointer, you get segfault. So here is if the list is empty, perhaps you should, exit one or, see out something. And then just return the default thing here. In this case, you could return a default card. But in this case, we'll do type 1. So there you go, made that function a little bit bigger. But that should do it. That should do it. So now I'm gonna keep moving forward with my whiteboard. And if anyone's got more questions, let me know. So I'm just gonna make a small kind of doubly linked list here. It's only gonna be a few of these things. I will do that. Can I make this bigger, please? Thanks. And we'll get some arrows going. And we need some previous arrows too. Don't forget those. Don't forget those. You are welcome. You are welcome. I can't see it. That's okay. That's okay. And so give me some ideas here. In the doubly linked list, where do you think that this arrow will be pointing here? This one that I'm drawing now. If it's not circular, if it's not a circular list, what do you think this one's looking at? And you can't see the other one. But I'll kind of pull it up here in a second. What do you guys think that this one's looking at? Yeah, null pointer. You guys are right. So I'll kind of put them here. Maybe we can make this bigger. All right, and so this one, we're just going to kind of look at it. We're just going to kind of look at it so we can, get some ideas about what's going on with our doubly linked list. So I'm actually going to bring this diagram in. So it's like this. And then when I scroll here, we should be able to see the end. We've got 4 objects, right? We've got 4 objects. And you can see that we got that going on. Okay, so we'll use this. And all we need for this is the code for the DLL. So we're going to go ahead and get started. We've only got about 20 minutes left today, so we probably won't get very much of it done, but at least we can get some nice kind of understanding. We can get started, and you guys can think about it. For the most part, singly linked lists and doubly linked lists are kind of the same, in just that we have to think about some extra things, which are those pointers, right? So this is going to be the DLL, but it's going to be the in-class DLL because I did do this one before class because I wanted to make sure that I got everything right. I know that debugging things usually helps you guys. And I'll try to do it in front of you, but I also want to make sure that I've got some working code to reference. So let's do template. Well, maybe to keep things simpler, this SLL is a template. Let's go ahead and just stick with an int for now. Let's just make an int DLL. And this one, kind of take note of this. This is maybe a hint for your assignment a little bit. I'm not going to straight give it to you, but just kind of think about what we're doing here. This is going to be a sorted doubly linked list. And let me put some comments here. This list will always be sorted. We will also not use a sorting function. So what does that mean? Whenever we insert a new object to this linked list, we're going to insert it in a sorted manner, okay? And that's kind of the hint for your assignment for something on there. I won't tell you what, but when you see it, hopefully you get some ideas. And so similar to all this other stuff, we need the code, right? So let's make a struct node, which is going to contain some data. It's going to contain a pointer to the next, and it's going to contain a pointer to the previous. Is everything okay? Why are you so mad? Why are you so mad at me? Okay, that's better. So all I wanted to do is snipping tool this and bring it into our diagram just so we can look at it. Right, there it is. That's our doubly linked list right there. And we're ready to go. So what do we need first? Well, let's probably do a head node. Head node's always good to have, and let's do an int size. Those are always good to have. So we're going to do quite a few things today. Maybe the first thing that we'll do is maybe a bracket. Well, we'll do a few constructors first. How about that? Let's do our sorted DLL constructor. I'm going to kind of just wave my hands for these ones before I start asking you any questions. Let's just kind of get the basics down, right? So this one's going to be pretty easy, right? If the list is empty, then we're going to initialize it to be a null pointer on the head, and we're going to initialize that size to be 0, right? That's an empty list. Now let's maybe do, I like doing these ones. What this one will take, and I've done this one before, it's just going to take an array. Maybe we'll do a constant array. And then the size of the array. And so we'll initialize our size to be the size of whatever that array is going to be coming in as. And then we're going to need to insert each element one by one. Now, because this DLL will always be sorted, I'm not going to worry about doing any of the allocation in this constructor. All I'm going to do is this. Now, I haven't written the function yet, but I know that I will. Where I is less than the size of the array, I++, I'm just going to call insert the array located at I, whatever that object is. And if this confuses you, we will call this insert array at I. Okay, so that one's done too. So add some comments here. This is our default, right? Our default. This is our parameter constructor, is what I'll call it. And then we got to do some rule of 3 stuff. So let's do that. Let's do that. Rule of 3. Let's do our destructor, the sorted DLL. Let's just, that one's going to be easy. All we'll do is this. We'll just say, you know, while. We've done this one a million times before, right? How do we delete an entire linked list? Well, while that head does not equal null pointer. Let's take some node. n is equal to the head, or the delete node. I like to name them things, right? This is going to be our delete node. Then we'll say that our head is equal to head next, and then we're going to go ahead and delete that delete node. All right, that's an easy destructor. Right, not too much code there. That's our destructor. It's all done. Now we're going to want, what am I doing? This is the destructor. Now let's go ahead and do our rule of three stuff, right? So the copy constructor, as I was saying, will be here. And what does that take? Well, that takes a constant sorted doubly linked list copy, right? And what am I going to do here? Well, I'm going to do this thing as I always do, except there's one thing I want to make sure that happens. The first thing is, let's make sure that our head is null pointer, and let's make sure that our size gets 0 first. Just to make sure that when we deallocate the list in our assignment operator overload, that we don't have any invalid reads and stuff like that. Right, I already talked about that today, how that might happen to you. So make sure that you initialize these parameters. And finally, we'll do the assignment operator. I kind of want to just copy this into a different function. It could be public. It could be public. I always like to have this clear list because it seems like we use it more often than not. So I'll just have a clear list function, which, right, this is the destructor. This is like your clear deck. And so in the destructor, I can just call clear list. We also do want to set the size equal to 0 in this function. Make sure you do that in your assignment 9 as well. If you're not doing that, that might cause you some problems as well. You know, when you clear that list, you want to make sure that the size is set back to 0. And so now in our assignment operator overload, this one will go by quickly because we spent some time doing one already. That's going to be a void. That's going to be an operator equals, right? What does it take? It takes the exact same thing that this one takes. And so the first thing we'll do is maybe clear our list. And then we'll say that our size is equal to the copy.size. And then let's do this. For int I is equal to 0, I is less than the size, I plus plus. I would like to do this exact same thing where I just call this insert the copy, and we'll get maybe data at, this one will keep more consistent with your assignment. I. So that one should be okay as well. I haven't defined these ones yet. Let's go ahead and do this one real quick, so you know what the one in your function would look like. Obviously, we haven't been doing anything with the previous nodes yet, but like I said, DLLs are pretty much the same thing as SLLs, except for a few extra pointers. So I want to call this thing here, whatever it is. In this case, it's going to happen to be an int, right? Because that is what our doubly linked list is for. So we're going to take some index here. Let's make sure this function is constant. And then we're going to do some traversal stuff, right? So we're going to say node. Well, let's do the checks. I always like to do the checks. If the index happens to be less than 0, or this index happens to be greater than or equal to the size of our array, let's just call an exit 1. Say, hey, this is an error. Probably print a message here, right? But you definitely want to exit out, or, you know, return some value that won't break your program too much. Other than that, we know that the index is in here, so we're just going to do the same thing that we always do, where the traversal node is equal to the headed node. And then for int I is equal to 0, I is less than that index, and then I plus plus. Let's go ahead and traverse that node. And then at the end, we will return whatever that traversal is, its data. Okay, that's kind of what your get card at would look like, right? Get data at, get card at. So in here, we're going to call that function. And once again, if you were to do this in your assignment 9, just start at the end. Start at the end and then call add to top of deck. Don't start at 0, start at the end. And then maybe your assignment operator will look like this. And then I guess we'll get started on our insert. This is kind of a big one. So let me see if there's anything else that I want to do. Oh, don't look at that. Yeah, actually, before I screw anything up with that, let me block that. Okay. Given some previous mess ups before, we're just going to be double careful about that. Alrighty, let's see what we got here. So I want to do the insert. We already did those ones. Yeah, there's really only going to be 2 more things we'll do, so let's kind of just put them here for now. We're going to do a void insert, which will take an int item, and we're also going to avoid delete, which will take an int index. This one will give us a good idea about what working with doubly linked lists looks like, and then delete will also give us kind of a good idea of what that looks like. But the truth is, like I said, I really don't want to get into this because it is a bit of a bigger function. So I'm going to kind of just call it for today. 5 minutes early. I don't think that's a big deal. So maybe I can just hang out here for a few seconds. If any of you guys want to ask some questions, any more questions, you guys did good with that today. Hopefully you're feeling a little more confident about assignment 9 now and you can get it done before tonight. Let's see. Cbase says, can you copy paste the get at function because you use it without defining it? This thing? I mean, yeah, I think so. But I guess I don't really understand your question. Perhaps could you rephrase it, or did I show you here that I kind of have that definition for it, so at least it works there? That's fine. That's fine. I get it. I get it. I was kind of, hopping ahead here, right? I hadn't defined this insert or the get data at, but I did it there, right? And that looks like any other thing that we've done. No worries. Is there anything else that anybody's got today? I'll go ahead and just hang the extra 3 minutes. I don't mind. And then we'll have some office hours at 1 p.m. as we always do. So if you do want to come by for a chat, you can. You can always just send me messages if you'd like. Today I'm not going anywhere for the rest of the day. I will have some of my own classes, but I usually respond to you guys in a timely manner, at least on Mondays. Don't forget to do your write-ups. I know the write-ups are annoying, but I don't want them to be annoying. You can just put a few sentences, not even a full sentence if you want, as long as you answer the question properly. And all we're checking for is to make sure you kind of understand or have some idea about what a linked list looks like, how it works, or, you know, in the templates and with the abstract class questions. We're just checking there to make sure you kind of have an idea about what we're talking about, right? Because I know definitely in some of these coding classes you guys take, I mean, I was there before. I've definitely taken classes where I work backwards from errors, especially when I took compilers. I just compile the code and work backwards from the errors until there's no errors. But then the code doesn't always work that way, right? Because just because you made it compile doesn't mean that it'll work. So that's kind of the point of the comprehension questions. Do you know what's going on? So make sure you do those. Some of you guys forgot them last time on assignment 7. And while I'm waiting out this extra minute, I'll go ahead and upload the stuff we did today to the class code so you can access it. How about that? I think that will be probably a good idea. All right, folks, I'm going to stop the stream, but everything will go up as it normally does. Video, code, notes, whiteboard, and all. Thanks for coming today, and I will see you next time.